Hello everyone, good evening and welcome back to my channel Math Changer, a game changer. I hope you all are doing well. So in the last video we have discussed regarding the type of fractions like proper fractions, improper, mixed fractions and equivalent fractions. Today we'll discuss regarding the addition, subtraction, multiplication and division of fractions. Before we proceed, let's discuss regarding the like fractions. So what are like fractions? Like fractions. Why we should know about these? Because only like fractions can be added, subtracted or compared. So for example, if we have a fraction like 7 upon 4, 9 upon 4, what is the common in these two fractions? You can see the denominators are same. And yes, the fractions which have the same denominator are like fractions, and only like fractions can be added, subtracted and compared. So the fractions which doesn't have the denominator same, like 5 upon 3, 7 upon 4, these are unlike fractions. So how we can add unlike fractions? You have to convert them into like. So any fractions which have to be added, subtracted or compared have to be like fractions. If they are not, we have to convert them. How do we can convert the unlike fractions to like fractions? By taking the LCM of the denominators. In the last video also we have discussed a little regarding LCM. In this class, let's discuss it once again. So LCM, as we all knows, it stands for lowest common multiple. And many kids, what they do is they just multiply them and then they say, okay, we'll take it as 12, because the basic um, the logic is you have to have the same denominator. So you can also just can multiply the denominators. If they are just two fractions, you can just multiply the denominators to make it a common denominator. But in that way, what happens is you get a bigger number, your calculations will become lengthier. So best is always to find the LCM. For example, what I'm trying to say is we have a fraction 8 upon 6 and 5 upon 12. Simple, it would have been, if you would have taken LCM of 12 and 6, it would have been 12, and in that way the calculation will be simpler. So if we don't know the LCM thing, what we do, we just multiply them and say, okay, 72 will take it. Yeah, not wrong, but the problem is you have to reduce the fraction to the lowest term once you get the final answer. So best technique is to follow the LCM method. Find the LCM of the denominators whenever we have to add and subtract any fractions. So if it is like fractions, yeah, very simple. If you have to add these 7 upon 4 and 9 upon 4, yeah, keep the denominator same. Never add the denominators. You only have to subtract the numerators. The 4 will remain the 4, and 7 plus 9 you can just write 16. And even you can cancel the things, and you get lowest form is just 4. So answer is 4. Let's take some other examples. I'll take it, yeah, up. Now let me take another example. I have a fraction 3 upon 5 plus 7 upon 4. Are these like fractions? Definitely not, because their denominators are not same. Their denominators are different. If the denominators are same, it's a very easy game then. You just have to add the numerators. But if it is not, you have to make the denominators same. As we discussed, right, we have to find the LCM of the denominators, and the LCM of 5 and 4 is 20. So what we need to do, you have to make each denominator equal to 20. For example, how can you make 5 equal to 20? Multiplying it with 4. Whatever you multiply with the denominator, you need to multiply with the numerator too. So 5 fours are 20, 3 fours are 12, plus, again you write 20 here. How can you make 4 equal to 20? We all know 4 5s are 20, 7 5 is 35. Please remember, whatever you multiply with the denominator, same thing you need to multiply with the numerator. Now we have the same denominators. These already had become like fractions, and now we can just add them. As we already have discussed, keep the denominator as it is. Don't just add 20 plus 20 equal to 40. That's wrong. Denominator, keep it same. Add the numerators. Add them. And that will become what? 5 plus 2 is 7. 3 plus 1 is 4. And that's our answer. Correct? So this is our answer. So how we have added them? Just let me minimize the screen. So our question was what? To add 7 upon 4, sorry, 8 upon 6 plus 5 upon 12. So what all we have done, we taken have LCM as 12 and then we have added it. And this time we have taken a question like add the fractions 3 upon 5 and 7 upon 4. We took the LCM of 5 and 4, which came out to be 20. And then we have converted each of the denominator 5 and 4 to make it 20. So always remember, we have to make the denominators equal to the LCM. So whatever you multiply with the denominator to make it equal to the LCM, same thing you need to multiply with the numerator. And once you convert the denominators same, you have to just add the numerators, not the denominators. So that becomes 20, 5 times 4 is 20, 3 times 4 is 12, 4 times 5 is 20, and 7 times 5 is 35. And then we added the numerators 12 and 35 to make it 47 upon 20. Let's take one example of subtraction. I'll take it up. Yes. uh, 9 upon 4 minus 3 upon 15 or just 12. Instead of 3, let's take it 5. Makes sense. Okay. So again, these are not like fractions. We cannot subtract them. So we have to convert them to like fractions. So again, we have to find the LCM. So as we discussed before also, what students do is they just multiply them and they say, oh yeah, 48 we can take. Answers will not come wrong. The only thing is, once you get the final answer, we have to reduce them to the lowest term. So to prevent all this, what the best thing is, find the LCM. So LCM of 4 and 12 is 12, right? So we have to make each one of them equal to 12. I will do one thing. I'll also show you once that what happens when you take just multiply the denominators. So as of now, we'll not do that. We'll take the LCM, which is 12. Now, how can you make 4 equal to 12? So very important that we should know the multiplication tables. So 4 times 3 is 12. Same thing need to multiply with the numerator as well. And that becomes 27 minus 12 is 12 only. So you need to just multiply with 1 and 27 minus 5, and which gives us answer 22 upon 12. You can reduce it to further, and that given, you just have to divide that with 2 and you get final answer as 11 upon 6. We'll also learn the divisibility test, which help us to know by which number we can divide it. For example, I divided it with 2, right? So why I only selected 2? Because these are even numbers, 22 and 12, both ending with 2. So any number ending with 0, 2, 4, 6, 8 are divisible by 2. So you can, because both were ending with 2 and because they are even, I divided it with 2. To know whether the number is divisible by 3, we'll also have another video where we cover up the divisibility tests and even the factors multiples concept, how to find LCM and GCF in detail. But yeah, to find the divisibility, to find whether the number is divisible by 3, or you can say the divisibility test for 3, we have to add the numbers. We have to add the digits of the number. For example, if I don't know whether 729 is divisible by 3 or not, I just have to add the digits of this number. So 7 plus 2 is 9, and 9 plus 9 is 18. And yeah, 18 comes in the table of 3, right? So this 729 is divisible by 3. So when you divide that with 3, you get a remainder 0. So we'll discuss all these things. So that will make, make your work easy, how we can reduce any fraction to the lowest term. Yeah. So what all we learned till so far? Addition of the fractions and the subtraction of the fractions. We'll do one thing. Now let's compare. Let's compare some fractions. For example, I have a fraction 7 upon 3 and I have a fraction 5 upon 4. And now I want to know which one is bigger or which one is smaller, or are these equal? I have to compare them. So how you can compare? Very it's difficult if the fractions are not like. If it is like fractions, then it's very easy. For example, if I have a 7 over 9 and I have a 4 upon 9, these are the like fractions. The denominators are same. The one with a bigger numerator is a bigger one. Simple game. But if it is not, if it is not like fractions, then same concept how we were using for addition and subtraction, right? We were taking the LCM and making the denominator same. We'll do the same here too. What we will gonna do? We'll take the LCM of 3 and 4, which is 12. So we'll try making them, both of them, 12. So LCM, so 3 times 4, 7 times 4, that become 28. And this is 4 times 3 and 5 times 3, and that becomes 15. Now we are not adding and subtracting. So what we'll gonna do? We just will compare the numerators. And if you see here, 28 is bigger than 15, right? So this fraction is only bigger. And this fraction is bigger means 7 upon 3 is bigger than 5 upon 4. So for comparing of the fractions also, same concept of addition and multiplication applies, that we have to make the denominators same by taking the LCM of the denominators. So one with a bigger numerator will be a bigger fraction. Make sense? Let's quickly cover up the multiplication and division of fractions. Yeah, we are covering up little less examples. What I will gonna do is, once we are done with the fractions concept, we'll make up. I will make a one worksheet and I'll post over here so that everyone can work on it. And any doubts comes up, yeah, we'll discuss in the next class. Yeah, 1 second. Multiplication of fractions is a very easy thing. Why? Because you just have to multiply the numerator with the numerator, denominator with the denominator. I will say this approach is okay, but best is you reduce to the lowest term. If any fraction is there, reduce them to the lowest term first, because then your calculation will be simpler. Else, if you just follow this, the numerator with the numerator, 3 into 5 is 15 and 4 times 3 is 12. Not wrong. But yeah, what happens? You have to reduce them to the lowest term. So I'll end up in dividing this with 3. So 15 divided by 3 is 5, 12 divided by 3 is 4, 5 by 4 is my answer. Because I just did numerator and numerator multiply with the numerator, denominator with the denominator. In multiplication and division, we don't convert any fraction to like fraction. That concept is only for addition, subtraction, and comparing. Here we just multiply. We don't see whether they are like or unlike. Just multiply the numerator with the numerator, denominator with the denominator. But yes, I was telling that we have to, it's good if we convert them into lowest term. For example, it would have been better if I would have cancel these threes. Now it's, see, straight away I get 1 into 5 is 5, 4 into 1 is 4. I don't have to reduce the final answer into lowest term. So how you can cancel? You can cancel the numerator with the numerator, or either of the same fraction or of the different I mean numerator with the denominator, either of the same fraction or the different fraction. See, I'm cancelling the numerator and the denominator of two different fractions. You can do that in multiplication. I can also, if this would have been, instead of 5, this would have been 16, so I would have cancelled like this: 1 times 4, 4 times 4, I can cancel that. Or if this would have been like 4 upon 16, I can even cancel Numerator and denominator of the same fraction. Either you can cancel the numerator and the denominator of the same fraction, or the different fractions is fine. And what concept we follow in multiplication is just multiply the numerator with the numerator, denominator with the denominator. Now, if we see the division, just one extra step. One extra step. For example, if I have 3 upon 4 divided by 7 upon 9, it's not like 3 divided by 7 and 4 divided by 9. No, it's not like, it doesn't work like that. How it works like in the case of multiplication, just multiply the numerator with the numerator and the denominator with the denominator. It's not like here divide the numerator with the numerator and the denominator with the denominator. No, just one extra step. And what's that? Keep the first fraction as it is, don't touch. Division sign makes it multiplication. And flip the next fraction. Flip, when I say make the numerator denominator, denominator numerator. 7 was my numerator, 9 was my denominator. Now it will be just ulta, other way around, 9 upon 7. And now same concept, what we have just learned in multiplication of fractions. Just multiply the numerator with the numerator, denominator with the denominator. So 3 times 9 is 27 and 4 times 7 is 28. This is my answer. So in division of fractions, just follow these 3 steps. What's the first step? What's the first step? Keep the first fraction as it is. Don't touch. Don't touch the first fraction. Just keep it as it is. Second, change the division sign to multiplication. If it is division, make it multiplication. Third, reciprocal of the second fraction. That's a mathematical language, reciprocal. Reciprocal means flip the fraction. Make the numerator denominator, denominator numerator. So that's the reason 7 upon 9, I had made 9 upon 7. Once you are done with this becomes the multiplication of fractions then. Just multiply the numerator with the numerator and the denominator with the denominator. So what all we discussed today? We have discussed the addition, subtraction, comparing, multiplication and division of fractions. Very simple, but yeah, though we haven't covered much of the examples, but as I told, in one of after once we are done with this concept of fractions, I'll post a worksheet where we'll have a variety of the questions, and we'll work on it. So I will ask you all to work on the fractions chapter, whatever the worksheet we have, and if any questions, we can post in the in the comment section, and in the next video we can discuss all those things. So fine, guys, I hope you had a good session, and I'll meet you people in the next class. Thank you.